Hi and welcome to day 11 of Just Start Programming, creating console terminal apps using Rust and Ratatouille. Today it's still more about widgets, as the other day I just spent some time to create shadows for the pop-up dialog. So we'll look into custom widgets as well today. Join me once again live in one take, no shortcuts and no secrets. So let's just start programming. All right, welcome back. Yeah, so last time we were trying out the pop-ups. We run this once again and see. Okay. Then today our topic is still more about widgets. Widgets. Use widgets. Okay, so widgets are types that implement the widget or stateful widget trait, which allows applications to render them to a terminal. The following pages document how to use the following widgets. So you have block, paragraph, custom widgets. There are more widgets available than just the above list. The crate docs document all the built-in widgets. See the widgets module for a list. There are also third-party crates that implement more widgets. Widgets module. Let's see. Okay, block, bar chart, calendar, canvas chart, clear, gauge, line gauge, list, paragraph, scroll bar, sparkline. What is sparkline? Sparkline over one more lines. Table and tabs. So those are the other widgets. Then there are also third-party crates. Third-party crates. References. Okay, so it's under references. NC to TUI. This is NC color codes and turn them into Ratatouille text. 8-bit. Color to TUI. Parse hex colors to Ratatouille style color. Example. Okay, so this one is, I think this is the one usually we see from color picker. Color picker. Hex color picker. Yeah. So something like this. Okay, so there are a lot here. Alright, so that's good to know. Let's continue. Let's start with block. Okay, block. Widget serves as a foundational building block for structuring and framing other widgets. It's essentially a container that can have borders, its title, and other styling elements to enhance the aesthetics and structure of your terminal interface. This page provides an in-depth exploration of the block widget. Basic usage. The simplest use case for a block is to create a container with borders. I think we have already tried block before. Block is here. Alright, let's clean up our code. Maybe let's comment this out first. Okay, so everything is clean. Let's run it here and see. Okay, so we shouldn't be seeing anything. And from here, let's try to do the examples. Okay, so simplest use case for a block container with borders. So instead of F, we change it to frame. Chunks, chunks. We need area, so we have frame.area. Frame area. Okay, so that's the basic block. Then you have tiles. A common use case for a block is to give a section of the UI. It's not tiles, it's titles. A title or label. Okay, so same example and then title was added. Title as header. Okay, and their title is over here. Then you can also use the line struct for better positioning or multiple titles. Okay, so in the previous example, we can only have one title. In this case, apparently we can have more than one. So let's try it out. Left title, middle title, right title. Okay. Oops. Somehow they overlap. So aside from title, you also have different border style. Okay, so maybe let's not skip, but keep the titles that we have here. And let's add the border. Border on. Okay, let's save this and run it again. Okay, so the border style is set to magenta. Then border type is rounded. Oh, nice. And then borders all. Okay. So I think this round border, I think we can use this for buttons also. If we create a custom button and we can use this rounded block. Okay, so that's for border style. Let's move on to paragraph. For a paragraph, widget provides a way to display text content in your terminal user interface. It allows not only plain text display, but also handling text, wrapping, alignment, and styling. This page will delve deeper into the functionality of the paragraph widget. Okay, so usage. Maybe let's skip the block. And here. In that area. Paragraph. Did it go? Ah, hello world. So it kept the style, which is the foreground color magenta. If we comment this out, then I think it will use the default style. Hello world. Okay. What else can we do? Styling and borders. You can also apply styles to your text and wrap it with a border. Okay, so we started with hello world, and we can add the style and border block. So hello world as the text, and then you have a style, foreground color yellow, and then you have a block with a border. Why is it rounded? Oh, okay, border type is rounded. Then you have title, and then foreground color is yellow. Not sure if it's just my terminal. Somehow the yellow color looks like brown or gold. Let's try. Maybe if we try from another terminal. I have here. Next term. It's too small. I don't know to increase the font. All right. Yeah, so I think this one looks more yellow. Okay, so I think it has something to do with the terminal. Okay, so styling borders, then wrapping. Paragraph widget will wrap the content based on the available width in its containing block. You can also control the wrapping behavior using the wrap method. Paragraph. Okay, so how about we use wrap, the existing one. Let's see. Right. Okay, let's compare it to this one without the wrap. How will it behave? Okay. So it's clipped off. Okay, so that's for wrapping. Setting trim to true will ensure the trailing white spaces at the end of each line are removed. Trailing white spaces at the end of each line are removed. Okay, trim true. Alignment. So in a paragraph, you can add this one, alignment center. Oh, there. It is centered. What will happen if we wrap the text and the alignment is centered? Okay, so it's still centered. Oh, that's nice. So it will retain the wrap around, and it's also centered. Okay, so is there a difference if I change the order? Okay, so the behavior is still the same. So paragraph, you can wrap the text, can align, can put in some styles, place it inside the block. What else can we do? Style text. Style text. Okay, so this one, hello, will have yellow as the foreground. World will have foreground blue, background white. Okay, let's try this. So from the code snippet, we can use it in actual project. Can make use of the sample Ratatui. And then we'll change F2 frame, and then chunks to frame area. So here there's a vector macro which contains span, and then why do we have push here? Okay, so because lines is a vector. Okay, so lines is a vector, so you have the vector macro here. Okay, so this is one line, then another line. So a line can have multiple span, but will it be hello world in one line or hello in one line and world in another line? Okay, let's see and find out. So yeah, so it's still interpreted as one line apparently. Yeah, but a line can have different span. So here hello is one and world is another. They look the same. Oh, okay, because the style are identical. Yellow, blue and white, then yellow, blue and white. Okay. Hello, Mr. Hoodie. Thanks for joining. And scrolling. Oh, this one is interesting. For long content, paragraphs support scrolling. So let's copy this one and see. So this is copy and paste programming. That should be fine. Anyway, we are still trying to learn Ratatui and Rust. Okay, so let's change this again to frame. And this one to frame that area. There's nothing here. What's wrong? Paragraph scroll offset P. Did we miss anything? For long content, paragraph supports scrolling. Okay. Scroll down by one line. What about if we use this one instead? Let's see. So apparently that one we won't be able to see anything. So instead of this, let's use text. Okay, so scroll offset 1, scroll down by 1 line. Okay, so originally we have hello world. Now we're only seeing goodbye world. It could be because of this one. I stretch this, nothing happens. So how about if we set this to 0, then we should set this to 0, then it should display both lines. Okay. How about if I move this to 4, 5? Okay. There. I thought scroll would have the scroll bar. Maybe that's a different one. Okay, let's see what else do we have here. Oh, that's it. That's it for a paragraph. Okay, let's move on to create custom widgets. Ratatui offers a rich set of pre-built widgets. There may be scenarios where you require a unique component tailored to specific needs. In such cases, creating a custom widget becomes invaluable. This page will guide you through the process of designing and implementing custom widgets. Okay, widget trait. Now, the core of creating a custom widget is the widget trait. Any struct that implements this trait can be rendered using the framework's drawing capabilities. So here we have my widget, content string, and then implement widget for my widget. Okay, so let's do this step by step. Maybe let's try this one. So here, okay, so this one is also a custom widget grid. So we did that in the previous exercise. And then here, another custom widget, which is pop-up. Okay, and then maybe we can append it here. Struct my widget. Then implement widget for my widget. Okay, let's start with this alone. And then do something like this, so that you will see this one we need to implement the render. Implement missing numbers. Okay. So that is the same as this one. Self area rect buff at mod buffer. Self area rect buff at mod buffer. Except for this one, of course. Then here the render method must draw into the current buffer. There are a number of methods implemented on buffer. Buff set string buff. So I think this is something new. Buff set string area left, area top, self content style. Okay, so let's copy this and see what shows up. So we can remove where, remove this. Okay, so what's going on here? Buffer sets the string of the buffer. Okay, so X and Y area, left, so upper left, top left. And then you have content. So content is taken from, okay, so self, from my widget. Content here as string. And then the style. We have style. Okay, so everything is still inside set string. Style, background green. Okay, so this one will not show anything unless if we add it here below. So frame render widget. And the widget is my widget. So we have, was it content string as hello world, and area for frame area. Oops. Area. Expected string. String from okay. Let's see. There. No world. So we've just created our own widget. Okay, then For a given state, the widget trait implements how that struct should be rendered. Okay, so this one is button. Let's copy this one and see how it looks. Okay, no errors so far. Under widget, just a widget, button, button. Label, label, label is string, so string from let's just put button. Okay. So next one is first. Next one is style. 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 What can we put? Style. Default. FG. Color. Blue. Okay, maybe that one. So color blue. Pressed style. Pressed style. Pressed style. Style. Default. FG. Color. Maybe yellow. Yellow. Okay. Oops. It's wrong. In that area. Okay, so what's wrong with this? Okay, so option style. So we can wrap it in some. So option will be some and none. Okay, so let's run this one. Nothing happened. Okay, so let's inspect style. Style is equal to if self is pressed. Okay, so I've set it to true. Self.pressed style and wrap or else style default blue. Else self style. Style if pressed. Okay, so if it is pressed, then it becomes blue. What did I do here? It's true. It's true. Okay. So it's true, then it will use yellow. Okay. That's why it shows up as yellow, because it is true. So if press style is not set, then it will become blue. Okay, maybe let's change blue to the color green. And let's set this to none. There. Oh, shouldn't be semicolon. And then frame area. So press this true, then it becomes blue. Oops. Doesn't take parentheses. Okay. So should be blue. Okay. And if this is false, it should be green. Okay. Yeah. Ratatui also has a stateful widget. This is essentially a widget that can remember information between two draw calls. This is essential when you have interactive UI components like lists, where you might need to remember which item was selected or how much the user has called. Here's a breakdown of the trait. Stateful widget. Type state. Render. Okay, so state is added and state is here. Type state. This represents the type of the state that this widget may use to remember details between draw calls. This method is responsible for drawing the widget on the terminal. Notably, it also receives a mutable reference to the state, allowing you to read from and modify the state as needed. How is it being used? Do we have this before? Search for stateful widget. I don't have it. What in other examples? Counter app. We have a stateful widget here. Yep. About JSON editor. UI. Okay, let's check. Render widget. Main, this is the app, the UI app. Should be in UI. UI, that's where we have the widgets. Okay, so we don't have any custom widgets. Let's look for examples. Let's go back to sample Ratatui. Stateful widget. Stateful widget graph in Ratatui. Use widgets. No, that's the same. Custom widget. Text area stateful widget should implement Ratatouille stateful widget. Text area stateful widget. Okay. Text area, so you have this, then text area stateful widget. When was this? March 8th. Stateful widget example. State plus 1. Okay. Where is it being used? In your draw function, render stateful widget. Okay, let's try this one. Widget for bottom. Can we use a state? Frame count widget. Okay, maybe we can use this example. Let's see if it runs. Frame count. Okay, so far no issues. Then let mat frame count state 0. So this one is in the main loop. Okay, let's put it here. Then frame over stateful widget is the widget. Frame count widget. So we need the style. Style. Oops. Style. Style default. Name that area. Frame count state. At mat frame count state. So what does it do? Frame count widget struct. Okay, then you have the style. Implements the stateful widget. This sign specify that the state for this particular frame count will be an I32, which will hold the frame count. This line demonstrates state modification by incrementing each time the widget is rendered. Okay, so we would expect that there will be a running number, since here the widget will have an increment. And it will display frame count. Okay, let's run this one. Cargo. It's only one. Each time the widget is rendered. How about this? So 0, 1, 2. Let's see. Okay. Frame count is 2. widget. So that's how you use it. Okay, so you can define a mutable variable somewhere, or I out this one and put it somewhere else. Where is the loop? The loop should be here. Run. Okay, so if we put inside app, let's try. State. Main count state inside app. Okay. Then where's run again? Okay, run is here. Terminal draw. Where can we insert that one? Inside run, it will call draw. Draw will call render. Okay, so let's copy this one. Let's insert it here. Self. What's that? frame count state. And let's come back to render. And here we will have frame count. Mm, 232. Frame count. Okay, so if you're passing it there, let's comment out this one. And then frame count. Okay, so I32. Let's change it to I32. And over here, it's the other error. And let's change it to I32. State. Um, Frame count. Okay. Consider mismatch. Consider mutably borrowing here. Okay, so let's see. Did not change. It did not change. Why? There's the run again. Run. So it's set outside. And here it's mutable. Frame count, I don't understand. So it means that it's still being rendered once, if that's the case. So this one will still set it to 2. And there was that example last time where we have the FPS. Where was that? Frames per second. No, this one is just the simple hello world. Set the counter up. Or is it the Ratatouille hello world? Here. Tick rate. Okay, so let's see. Main, so main you have init, then you have run. Inside run you have Okay, so this one is async. Tick rate, frame rate. Is there a custom widget? There's no custom widget here. Okay, so this one is refreshing. But that one doesn't look like a custom widget. Render, TUI draw, component. Okay, so create component. Handle events. FPS counter. Okay, so this one is not a stateful widget because here you can see it's still render widget. So render widget. Okay, so this is not the one. Stateful widget. Okay, so for render stateful widget, is that some external value, and inside this one, you can pass in the state. How is it done again? Render stateful widget. Frame count. Frame count widget. Okay, so for frame count widget, we only have the style. Okay, so frame count widget will have the style. Frame area. So the frame count is outside, but in the widget itself, once it is rendered, it will make use of the state. So state could be anything you define here. Type state defines the type of the state associated with this widget. So state in this case is I32. So state can also be different data types, but it makes use of the state here that you can change inside when you are rendering. And then by calling this render as a stateful widget, it has to be render stateful widget. Okay. That's for stateful widget. Yeah, so it would be nice if there's an example here as well. All right, so I think we don't have time left. Yeah. So maybe in the next day we will go through testing. What's in here? Testing with Insta snapshots. Okay. Cargo Insta. What is this? Abstract. Oh, okay. So you can make use of test cases to test your UI. Then you can do a search snapshot. Okay, so maybe this one is only for Cargo Insta. Terminal backend. So how your UI will look like, you can do some assertion. Running the test. So you can print something like this, and if the UI looks like that by assert, then maybe the test will pass. Handling snapshot changes. All right, so let's do that on the next day. And maybe this one is a huge topic as well. Maybe this will take 4 or 5 more days at least. Yeah, but let's go through these topics one by one. All right, thank you so much for joining me today. I hope you learned something as well. And let me thank my supporters.